uses multiple stages of encryption and thereby significantly more difficult to cryptanalyze. Rotor machine essentially depends on rotor principle. A machine consists of a set of independent rotating cylinders through which electric pulses can flow. In World War II, Germany uses Enigma and Japan uses Purple. Both are encryption machinery that uses this rotor principle. And the breaking of both of these has a significant factor of World War's outcome. Now, as I said, the machine consists of a set of independent rotating cylinders through which electric pulses can flow. How it operates, each cylinder has 26 input pins and 26 output pins with internal wiring that can connect each input pin to a unique output pin. Consider this figure, one cylinder I have shown here. So input pin, this side these are input pins and this side these are output pins. So in input pins, this is in certain condition I have these numberings 1, 2, 3, 4 up to 26. And when it rotates, then this 23 goes up here. It is essentially a cylinder, so it will go up 23 here, 25 1 down like that. So 1 is taking the place up to like that. And again, if you press, it will the 22 will go up, then followed by 23. So here one intermediate step is shown. Initially, it was like 1, 2, 3 up to 26. Then once it rotates, it keeps on rotating. And after 26 rotation, it will come to the original position. And input pin is connected to the corresponding input pin, output pin here. So this is one cylinder I have shown, and when you press A is pointing to the input pin 24. So electric pulse will go along this wire, and output will be Y, corresponding Y. So there is you press the key, and in that side, on that side, maybe these are some light bulbs. Okay, so when your electric pulse goes through this, then this bulb, this bulb will be switched on. So each cylinder has 26 input pins and 26 output pins with internal wiring like that. And that connects each input pin to a unique output pin. Each input and output pin is associated with a letter of the alphabet. So this input pin corresponds to a letter, and this output pin corresponds to another letter. Okay, so when you press A, output will be Y, and the cylinder will rotate once. Okay, so in the next step, what will be the condition? So this 23 goes up, and correspondingly 24, 25 is coming down, and same this 23, 13 is going up essentially. Okay, 23 this side, 13 this side. The whole cylinder rotates one position down. If I say it is rotation direction is downwards, then after depressing A, you get the output Y, and after that the cylinder position is like that. Input pin, output pins are in that way. So 23 goes up. So 23, and this wiring, whatever wiring corresponding 23 output position is T. So when you press A again, then you get instead of Y, you get this T. Like that. Again you depress T, again you depress A, you will get some other thing. Okay. So single cylinder, if you have a single cylinder, it defines a monoalphabetic substitutions. single cylinder rotation, it gives you monoalphabetic substitution, and you can easily feel that after 26 rotations it will come to its original positions. It will come to its original position, and the repetitions will occur. So here the same thing actually illustrated here. Input pins 24 corresponds to A, this 24, and the output pin this 24 corresponds to Y. So when you press A, electrical signal is applied to the first pin and flows through the internal connection to the 24th output pin. So you get Y. And after that, cylinder rotates one position. My direction of motion is downward. So after that, this all are one position down. So 24 comes in the second position now. 25, third position, like that. So 24, 21, 24, 21, 25, 3, like that. And the last one comes up. 23, 13 comes up. So again, if you press A, then 23, now A corresponds to the pin number 23, and this 23 corresponding output pin, it is U. So you get U. And then it rotates. So now the condition of the cylinder is this is all shift downwards one position. So now 22, 24, 20, this the last one is 22, 24. So it is coming top and remaining this. So when you press A again, then 22 connection, that is O, you will get O, like that. Okay. So here essentially in this side input pin we have all the numbers 1 to 26, and at the output pin positions they are essentially one permutation of this. So one transposition we are actually using. And so we get one substitution, monoalphabetic substitution in this way. So this is your initial setting after one keystroke, setting after second keystroke, like that. Okay. So single cylinder system does not present a formidable cipher cryptanalytic task. So you can easily cryptanalyze this one. So we have shown here use of three rotors. So this is your first cylinder, okay? The first cylinder, and input pins 24. This input pins is connected to output pin here. The second cylinder input pin 24. This connection is connected with this 24. It is going here. And third rotor, I am also using a third rotor. So, so wherever it is going, this is the last but the one place. So from that place, it is going where whatever number it comes. If so, I have whatever number here, it will go there. And then whatever number corresponding to this position, it will go to that. And finally, you get. If you press A, you will get B. Similarly, suppose you press B. So B corresponds to input pin 25. So corresponding 25 position is this one. So this position is connected to this position 22, and then this position is connected to 13. So you get I. And after each keystroke, this is the outermost cylinder. This outermost cylinder moves one position. Okay, so this is the fastest rotor. So once it completes its 26 rotations, then it comes to this original position, and in that case, the second, the middle rotor rotates one position down. So 26 rotations, once it completes the 26 rotation, the faster rotor, the medium rotor rotates one position. Now, after 26 rotation, completion of 26 rotation of medium rotor, the slow rotor rotates 1. So essentially, you get how many substitution cipher? 26 into 26 into 26. Okay, so for 26, each of these 26 rotations, you get one rotation here. For each of these 26 rotation, you get one rotation here. So we get 26 to the power cube, this many monoalphabetic, this many different substitution alphabets used before the system repeats. So if you press A, the first position you get this is 20. So this is 20. A is 24. Connection is 24. We'll go for 24, and then this one corresponding position here, it is also 24 here. So corresponding this position 18, it is taking you to 18. So you get B. So once this is done one keystroke, so this rotor, the slower rotor, faster rotor moves one position down. So in the next level, this rotor, this first rotor positions are like that. 2614 is going up, 2614 is going up, and all this shifted one position down, 1, 8, 2, 18, like that. Okay. Now mind that this these input alphabets, these are fixed, and these output alphabets are also fixed. But here, these positions, these are input pins, and these output pins in internal wires. They are connected by internal wires. Electric pulses goes through them, and this side is essentially one permutation of this side. Similarly, this side is essentially one permutation of this side. This side is essentially one permutation of this side. 3 different permutations we have utilized. So 3 transpositions actually we are applying, not only one transposition. So after pressing A, you get B. Then again, if you press A, what you get? If you press A, once you press A, the position of you get B, and after that, this rotor takes the position. Its internal connection is like that. So when you press A again, in that case, A is taking you to here, then here 24, and since this rotor moves one position, internal connection moves one position down, so here this position is now taking the place 17. So it is coming down. So it is 17. So 1725 is essentially coming. So 17, wherever 17 you are taking, that you will get. So you are getting E, the next part. So once you get E, it will again rotate. So it will again rotate. So 25-1 will go up, and all these things will go down. So the position is like that. 25-1 now, then all positions are coming one position down. Okay, so when you press A again, then this is taking you to here, this is taking you to here, but now this one is moved down twice. So 18, 17, now your position, this position is essentially 16 position. So your 16, wherever it is taking you, that is your output. Okay, so you get T. And after that, it rotates once again. So 24/7 is going up, all are coming down this way. Okay, so this working procedure is written here. Multiple cylinders used with output pins of one cylinder are connected to the input pins of the next. Output pin of this wire is connected to the input pin of this rotor is connected to input pin of this rotor, corresponding positions. For every complete rotation of the outer cylinder, the outermost cylinder is the faster cylinder, first cylinder, means it is fast rotor. Okay? So outermost cylinder, every complete rotation of outer cylinder, the middle cylinder rotates one pin position. And for every complete rotation of the middle cylinder, the inner cylinder rotates one pin position. So this is the slowest rotor. This is medium rotor. This is the faster rotor, fast rotor. So this produces 26 into 26 into 26. This many different substitution alphabets before system repeats. Okay. Okay, so let us stop here. Rotor machine. We have completed the classical cryptography. In our next class, we are going to discuss lock cipher, string cipher, symmetric ciphers. We will start that.